Refuse-derived fuel or solid recovered fuel/specified recovered fuel is a fuel produced by shredding and dehydrating solid waste with a waste converter technology. RDF consists largely of combustible components of municipal waste such as plastics and biodegradable waste. RDF processing facilities are normally located near a source of MSW and, while an optional combustion facility is normally close to the processing facility, it may also be located at a remote location. SRF can be distinguished from RDF in the fact that it is produced to reach a standard such as CEN/343 ANAS. A comprehensive review is now available on SRF/RDF production, quality standards and thermal recovery, including statistics on European SRF quality. Processing. Non-combustible materials such as glass and metals are removed during the post-treatment processing cycle with an air knife or other density separation technique. The residual material can be sold in its processed form or it may be compressed into pellet fuel, bricks or logs and used for other purposes either standalone or in a recursive recycling process. RDF is extracted from municipal solid waste using a mix of mechanical and/or biological treatment methods. The production of RDF may involve the following steps: bag splitting, shredding, size screening, magnetic separation, coarse shredding, refining separation. The mix of materials should be cut to particles not bigger than 25 mm/1 inch. The moisture content of the mix should not be bigger than 15% because if so the materials will not burn well in the furnace. The particles will last between 17 to 18 seconds in the furnace, usually in a temperature of 1200 degrees Celsius/2192 degrees Fahrenheit. End markets. RDF can be used in a variety of ways to produce electricity. It can be used alongside traditional sources of fuel in coal power plants. In Europe, RDF can be used in the cement kiln industry, where the strict standards of the Waste Incineration Directive are met. RDF can also be fed into plasma arc gasification modules, pyrolysis plants, and where the RDF is capable of being combusted cleanly or in compliance with the Kyoto Protocol, RDF can provide a funding source where unused carbon credits are sold on the open market via a carbon exchange. However, the use of municipal waste contracts and the bankability of these solutions is still a relatively new concept, thus RDF's financial advantage may be debatable. Measurement of the biomass fraction of RDF and SRF. The biomass fraction of RDF and SRF has a monetary value under multiple greenhouse gas protocols, such as the European Union Emissions Trading Scheme and the Renewable Obligation Certificate Programme in the United Kingdom. Biomass is considered to be carbon neutral since the CO2 liberated from the combustion of biomass is recycled in plants. The combusted biomass fraction of RDF/SRF is used by stationary combustion operators to reduce their overall reported CO2 emissions. Several methods have been developed by the European Centre 343 Working Group to determine the biomass fraction of RDF/SRF. The initial two methods developed were the manual sorting method and the selective dissolution method. Since each method suffered from limitations in properly characterizing the biomass fraction, an alternative method was developed using the principles of radiocarbon dating. A technical review outlining the carbon-14 method was published in 2007, and a technical standard of the carbon dating method was published in 2008. In the United States, there is already an equivalent carbon-14 method under the standard method ASTM D6866. Although carbon-14 dating can determine with excellent precision the biomass fraction of RDF/SRF, it cannot determine directly the biomass calorific value. Determining the calorific value is important for green certificate programs such as the Renewable Obligation Certificate Programme in the United Kingdom. These programs award certificates based on the energy produced from biomass. Several research papers, including the one commissioned by the Renewable Energy Association in the UK, have been published that demonstrate how the carbon-14 result can be used to calculate the biomass calorific value. Regional use. Iowa The first full-scale waste-to-energy facility in the U.S. was the Arnold O. Chantland Resource Recovery Plant, built in 1975, located in Ames, Iowa. This plant also produces a DF that is sent to a local power plant for supplemental fuel. Manchester the City of Manchester, in the northwest of England, is in the process of awarding a contract for the use of a DF which will be produced by proposed mechanical biological treatment facilities as part of a huge PFI contract. The Greater Manchester Waste Disposal Authority has recently announced there is significant market interest in initial bids for the use of a DF which is projected to be produced in tonnages up to 900,000 tons per annum. Bolmer currency S equals, during spring 2008 Bolmer currency S Ovanienkers Reinhar Järnlings AB in Sweden, started their new waste-to-energy plant. Municipal solid waste as well as industrial waste is turned into refuse-derived fuel. The 70,000 to 80,000 tons RDF that is produced per annum is used to power the nearby BFB plant, which provides the citizens of Bolmer currency S with electricity and district heating. Israel in the fall of 2013 a cornerstone-laying ceremony for the new refuse-derived fuel plant in Israel took place at the Hyria Recycling Park near Tel Aviv. The future RDF plant will be operational for 20 years, hoping to convert 540,000 tons of annual waste into fuel. The fuel is produced by shredding and dehydrating municipal solid waste with a waste converter. See also, biodegradable, cement kiln, Isle of Wight gasification facility, mechanical biological treatment, mechanical heat treatment, waste to energy. References: CENTC 343, Published Standards, Belize CAL. Production and Quality Assurance of Solid Recovered Fuels Using Mechanical Biological Treatment of Waste, A Comprehensive Assessment, Williams, P. Waste Treatment and Disposal. John Wiley & Sons, Chichester, European Committee for Standardization, List of Published Standards, Arnold O. Chantland Resource Recovery Plant, www City Ames EOS, Retrieve 29.11.06. Healthy Interest for Manchester Waste-Derived Fuel Contract, www.letcycle.com, Access 20.11.06, Manchester seeks outlets for refuse-derived fuel, www.letcycle.com, Access 20.11.06, BORAB, Waste-to-Energy Plant, Access 03.03.11, Bioenergetechningen, New Waste Mill and Bolmer currency S, Access to 3.15.11, New Waste to Energy Fuel. Plant gives trash a future, Access 10.30.13.